Josh Long. And Josh, or at Starbucks Man, has been the first Spring developer advocate since 2010. He's a Java champion and author of 6 books and numerous best-selling video trainings, including like the Building Microservices with Spring Boot live lessons. And an open source contributor and podcaster, so he's a really multi-talented person. He's also a YouTuber. But today he's here to speak about the cloud-native Java. So Josh, the stage is yours. Please share your idea about that.
Well, good afternoon, everybody. Good morning to some other people like myself. I'm in San Francisco in the United States. It's morning here, so I wish I could be there with you in person. Obviously, it's a wonderful show. When I was there last time in person, I had a wonderful time. I only wish I could return. It's a crazy year. So we won't spend too much time. My name is Josh Long. I work on the Spring team. Oh, get some air in here. My name is Josh Long. I work on the Spring team. I'm a Spring developer advocate, a Kotlin Google developer expert, and a Java champion. And most importantly, I am at your service. So if you have questions, when you have questions, don't hesitate to reach out to me. There's my Twitter, there's my email, etc. Also, there's the code. So if you want to follow along, you can watch the code there. Now, today, my friends, we're going to talk about cloud native Java. Now, this is the whole point of cloud native Java is not to talk about any one particular set of technologies. Obviously, I love Spring, but it's not the only thing out there, right? When we talk about cloud native Java, what we're talking about is an approach that optimizes for learning. How quickly can we iterate? How quickly as an organization can we improve our software? The goal here is to build software that is meant to allow us to go quickly and to improve in production, etc. And so there's a lot of things that you can do to build software in such a way, right? Obviously, you've heard about a lot of the buzzwords from the last 20 years. You've got cloud computing, test-driven development, continuous integration, microservices, etc. These are all about going faster. One particular practice, microservices, is a very simple idea. It says that organizations that have a lot of people working on one code base are slower than small code bases with small teams. So break the large teams into smaller ones and have them focus on small batches of code. The smaller the batch of code, the less people, the easier it is for them to integrate, stabilize, and deliver changes into production. The faster they can get the results from that, the faster they can improve. And so usually people look at their microservices, their monoliths, and they decompose them into small batches, and they find something like a bounded context or an aggregate maybe, and they use that as the boundary for this decomposition. And so when you think about the costs, yes, there are costs to microservices. Of course there are, because it's more complex. You've got moving parts, you've got a distributed system, and you risk running afoul of the problems of being in a distributed system. But the benefit, if done correctly, if you make it so that it's a whole systemic thing where the whole organization is optimized for agile iteration, the benefit is that you as an organization can deliver better software faster. And so that's why people do this. But that is, that's not to say that there is no cost. There, of course, is a cost, like I just said. And so today, we're going to talk about some ways that you can pay down some of those costs with Spring. And a lot of those costs arise from the fact that you're building a distributed system, which means that you have the fallacies of distribution that you have to deal with. You have the faulty assumption that the network is always fast. You have the faulty assumption that the network will always be there, etc. And so we need to first of all write software that's more robust. We need to write software that's more efficient, because when you move to a distributed system, now a lot of the communication is being done over the network from one service to another. And finally, you need to write software that's more robust, because now things will fail, and so you need some way to deal with that. So today, my friends, we're going to write some software, as always, by going to my second favorite place on the internet. Obviously, my first favorite place is production, but my second favorite place is start.spring. And what we're going to do is we're going to build an application here called Customers. And this is going to be a reactive application that uses reactive data access. We're using an in-memory embedded SQL data store called H2. We use Lombok, and we're going to use the Spring Boot actuator. Now, this is just going to be a regular service, a microservice, but I want to also optimize it for production. So I'm going to build a native application as well. Now, when I build this application, I'm going to be using reactive programming. Reactive programming, we could go very deep into this, but what you need to understand is that it gives us 3 big benefits. The first big benefit is that it makes it easy to reuse threads. Right now, while we wait for Project Loop, threads are very expensive on the JVM. And so we want some way to make sure that we never waste them, that we never spend time waiting for IO on the thread when we could give the thread back to the runtime. This allows us to scale, to handle more requests in the same virtual machine. It's about making one individual transaction faster. It's about making it so that we can handle many, many, many more transactions. The other benefit that you get from reactive programming is that you get a single unified programming model. That programming model allows us to integrate easily. It supports ease of composition. So I can take data from Kafka, from web services, from service and event streams, from WebSockets, from RabbitMQ, from whatever. It doesn't matter. It's all the same kind of data type. Right now, if you look at all the different imperative non-reactive APIs, you've got different APIs for Kafka, different APIs for RabbitMQ, different APIs for data from a REST endpoint, etc. With reactive streams, because it has a nice type that you can use to describe data, no matter what the shape and size of it, doesn't matter if it's asynchronous, doesn't matter if it's synchronous, it doesn't matter if it's small or large or unlimited, it doesn't matter if it's slow or fast, you can use the same exact type. It's called a reactive stream. And then because we have one unified type, that gives us a third benefit. And that third benefit is that we have a single place where we can add operators to support reliability, to support robustness, to do things like retries and timeouts and circuit breakers and so on. All that can be done in a single place. You don't have to bring in different libraries to introduce this kind of support into your code base. So reactive programming gives us resource efficiency, ease of composition, and robustness. Okay, so we're going to take advantage of that. We're going to write an application that talks to a SQL database. Now, this SQL database is going to have a table called customer, and I'm going to map an object to that SQL database using this entity here. And because it's a SQL object, I need to create a SQL table. So what I'm going to do is I'm going to go here to source main resources, and I'll create a file called schema.sql. And this will get run when the application starts up. So I'll create table, customer, ID, serial, primary key, name var car, 255, not null. Okay, so there's my basic table. And now what I want to do is I want to write some data to the database, and I'll create a repository. And this is just basic data access support here. So I'll use Spring Data's repositories, and here we go. And I'm going to create a bean that gets run when the application starts up, called a initializer. It's going to be an application runner. And this is going to be a place where I write sample data to the database. So I'll instantiate the object, here we go, and we'll inject the reference to the customer repository, and there we are, okay? So there's our required args constructor. And what we're going to do is just going to write some names of people in the Spring to the database. These are people on the Spring team. I'm going to create a reactive stream of type Flux. This is one of 2 specialized types that descend from something called publisher. This is the unified reactive streams type from which all these other things will descend. So this stream will have a few people in it. Madura, Josh, Olga, Violetta, Yushin, Elia, Spencer, Stefan, etc. Okay, so there's some nice simple names, and we're going to visit each name and turn it into a customer. So for each name, we're going to turn it into a customer. And then, of course, this is just the stream of names. I need to now turn each name into a record that's been written to the database. So I will call repository.save, and this is my saved data. All right, so now I've got a stream full of things that have been written to the database, but nothing will happen because you see, reactive programming is it's like a pipeline. You have to turn on the water, turn on the faucet to see the water. So in order to do that, you subscribe. But this is an asynchronous operation, so you cannot guarantee that this will happen. You can't guarantee that this will happen after this. You need to use the operators to make sure that certain things happen in a certain order. So let's say I wanted to get all the data, and then I wanted to say saved dot then many all dot subscribe, right? I'm going to say dot subscribe, print line. Okay, so there's my little pipeline I've defined. Let's run the program. If we run the program right now, we'd see the data in the database. Actually, I want to create a REST controller as well. Class customer REST controller. And I'm going to create an endpoint here that returns all the customer data. Publisher of customer get. So this is an HTTP endpoint I'm creating. I'm going to use my repository to do that work. So I'll say, return this repository find all. And of course, I'll inject this through Lombok, a compile time annotated constructor created through Lombok. So let's go ahead and restart this. Localhost customers. There we are. So that's working just fine. Now, I have some data in the database. Are we ready to go to production? Of course not. The next thing I care about is observability. So I need to expose these actuator endpoints, right? The actuator are a set of managed endpoints that give me information about the state and health of the service. So I'm going to expose a few different probes here. This is for my demo. Obviously, in real life, you would not want to expose all of these endpoints without at least using security, which is pretty trivial to do, but I will just forego that for want of time. So now if I go back to here, here's my app, go to actuator, you can see we have these different endpoints that give you information about the service itself. Things like the beans endpoint, which shows you all the objects that have been wired together, the caches endpoint, which shows you all the cache manager implementations in the application, the health endpoint, which gives you a list of all the subsystems in your application that might fail. So your file system, you have your database connection, you have your Kubernetes liveness and readiness probes, which we'll talk about in a second. You have also your info endpoint. Your info endpoint is a good place to put identifying information about your service. So one example is that you can actually go here and just say info.id or info.message equals hello world. Okay, so I can actually just describe arbitrary messages. Another thing you might do is to use the git commit ID plugin that Spring Boot pre-configures for you. Git commit ID plugin. Okay, there you are. You can use that and then bring that into the build down here. So this plugin is already configured. I'm not going to do anything. I'm just going to stop the application and turn it into a Git repository. Okay, so there's my brand new Git repository, git commit YOLO. Okay, so now I've got to build Maven clean package. And what that's going to do is it's going to give me a application that has been compiled and a code, a little file called git.properties will be generated when the application starts up. Or rather when the application is compiled, and you can see all that has already been packaged into my application. So now if I restart this application, okay, and we visit here, you can see it says message equals hello world and the branch and the git information. So now when you have a continuous delivery pipeline, you make changes, you do git push, it goes to the CI environment and then to the CD environment and then gets deployed to production. Now you know what version of code compiled, right? You know which one passed the tests. Very convenient. So all of this is very useful, right? Because now you have the ability to trace where an error might have originated. So you can do git bisect and all that kind of stuff. So we have, what else do we have here? We have the conditions endpoint we have the env endpoint, which shows me all the environment properties, environment variables, system properties, that kind of stuff. We have the heap dump and thread dump, which show you heap dumps and thread dumps. You can dump the heap dump into a profiler. You have the metrics endpoint, which gives you keys and values, statistics for low cardinality data. These are like aggregate numbers, median, mean, count, etc. This is powered by something called Micrometer. Micrometer is a vendor-neutral application metrics facade that we built that has integrations with all sorts of different time series databases to help give you that single pane of glass. We have a lot of other endpoints, but I did mention the health endpoint, and to me, the health endpoint is one of the most important because it has those probes, right? So when I say production today, for a lot of people, production is Kubernetes. So what we're going to do is we're going to use this application in production. We need to support these two probes. The readiness probe tells the application if it tells the container orchestrator if the service is ready to be put in production. The liveness probe tells us whether the service is should stay still in production. Okay, and so when Kubernetes sees this, it's going to then shut down the application. If the probe is down, it's going to shut down the application. And then you have to decide, do you want the container orchestrator to shut down your service immediately, or do you want it to wait a little bit and give you some time to finish your work? We support that modality using something called graceful shutdown. So shut down, graceful, okay? So I've got now configuration for Kubernetes. I've got this message up here, but let's say I wanted to have a configuration for just hello Kubernetes. So if I want to run something, if I want to run configuration in only inside of a Kubernetes cluster, I can do that. I can say activate on cloud profile, right? Or cloud platform, and then I can just say Kubernetes. So everything after the dash and the hash and 3-, everything after that is Kubernetes specific. Okay, so and you can restart this, and you can actually tell the platform. You can tell Spring what cloud platform it is to debug, but obviously in Kubernetes, you don't have to do this. So on my local machine, I'm going to restart the application, but I'm going to start it with a property in the environment. So that way it's not part of the code itself. I'll say -- spring.main.cloud platform equals Kubernetes. I'll hit OK, and I'll hit restart. Okay, so go to info. There's my information. It says hello Kubernetes, etc. So it thinks it's running inside of Kubernetes. If I remove this, right, it'll go back and show me the old hello world, which is what we want. Now, I have an application that will do the right thing in a Kubernetes environment, right? Oh, by the way, here's hello world. Okay, so now we have code that's ready to go into production. I've stored my configuration here. I may want to get that configuration from outside. I may want to store that configuration in the Spring Cloud config server, or in HashiCorp Vault, or in config maps. And if that's the case, then you can import that here. You can say import config tree, and then you can point it to a directory, right? So a path where the config map is mounted. So imagine we were running inside of Kubernetes right now, and we had a directory full of configuration called config. I go to the desktop, make dir config, cd config. In a config map mounted volume, you have, let's say, 8020. We put that in a property in a file called server.port. So the property is called server.port. The value is 8020. I'm going to expose that information as a directory. And because we're going to be running inside of Kubernetes, it'll mount this configuration and it'll override the default port. Usually, by default, Spring Boot starts up on port 8080, but here it's on port 8020 because it's reading that configuration. So we have now an application that is doing the right thing. We can get configuration. It's got configuration specific for Kubernetes. It's got liveness and readiness probes. I think we're ready to go to production. Don't freak out. I didn't say we have to create a Docker image. I just said we have to go to production. There's a difference. I think that we can do a lot better, and we should do a lot better. So what I'm going to do is I'm going to use build packs. Now, build packs are a cloud native computing foundation technology that turn your application source code into a container image that can run on any cloud. This is the work from Heroku and then Pivotal, where the Spring team was before, and we donated that work, and it became the cloud native build packs. Now, there's an implementation of all these different build packs, these builders, from a project called Paketo, and so you can use Paketo to build containers for lots of different kinds of applications, including JVM applications. One very interesting possibility is using it to build native images for graalvm. And so we support that. When I went to start.spring.io, you might remember here, I chose Spring Native. It's experimental, but what this does is it helps turn your application into a graalvm native binary. So we're going to use build packs to create a Docker container for our code, but it's not just our code. It's going to be a native image as well. Okay, so that build pack will do all the work. I'm not even running graalvm on my local machine, but this will create a container, and inside the builder, inside the container, it'll download the graalvm runtime and the native image compiler and do all the compilation, and then give us the resulting container so that we can deploy that to a cloud of our choice. So here we'll say maven clean package spring-boot build-image. Now that'll take several minutes. It's not quick. And so actually, you know what? I'm going to stop it right here. We'll do it here. Okay. Maven clean package spring-boot build-image. All right, good. So we have now our application. I want to now build an application that we can talk to, right? I want to build another microservice. So I'll go to start.spring.io, and here I'm going to build the order service. And here I'm not going to use HTTP, which has several limitations. I'll use RSocket. RSocket is a binary protocol that was created by engineers at Facebook and Netflix, and that gets around the limitations of HTTP2 and gRPC and so on. It's a very, very fast binary protocol that supports the ideas of reactive programming as a protocol. So it includes this concept called back pressure. We don't have a lot of time to get into it, but all you have to know is that there's a very convenient integration in Spring already, and so we can just use that. So I'm going to create a new service for the order data. So we have customer data, and now we have order data, okay? And I'm going to build an RSocket controller like this, order RSocket controller. And we'll create a constructor. Okay. And I'm going to create a map, a little in-memory database, if you will, of my data. So map integer collection of order db equals new concurrent hash map. Okay. So there's this map. Good, good. So we're just gonna write some hard-coded data. We're gonna write some customer data starting at 1. Customer ID is less than or equal to 8. Customer ID plus plus. Var orders list equals new array list order. For var order ID equals 1. Order ID is less than, let's say, some random number. Okay, so I'm just gonna create 100 records or so. And then we're gonna add that to the list. So we'll say orders list dot add new order. And then the order ID will be on the left, the customer ID on the right. And then we'll say that this is all part of the database. So when a client comes and says, hey, give me all the orders for this customer, we'll give them this list of orders, okay? And in order to support a client coming to us and asking that question, we need to create an endpoint. So orders.customer ID. I'm going to create a reactive stream that returns all the order data here. So get orders for destination variable, integer customer ID. Okay. So we're going to say this.db.get customer ID, and we're going to turn that into a stream. So a reactive stream from a collection, and voila. Okay. So this is our RSocket service. We need to start it up on a custom RSocket port. So it's not HTTP, so I'm going to use the custom port here, 8181. Go ahead and start this. Okay, so we have that, and we can interact with it. We can say RSC. Instead of using curl, we say RSC, localhost 8181. The route is going to be orders dot, let's say 2, and the interaction type is a stream. Okay, so there's our data. Now, let's build an edge service. Okay, an edge service is the first port of call. It's where it's the gateway for new requests coming into the application. And here we can do RSocket and HTTP. We can handle generic cross-cutting kinds of concerns, things like routing, compression, load balancing, security, authentication, authorization. All these things are very easily handled in the gateway. We can do this using an API gateway or API adapters or both. So let's take a look at that. To support API gateways, we have this project called Spring Cloud Gateway. And Spring Cloud Gateway is an API gateway that gives you the ability to define a route locator builder. To define routes, so you say routes.route, and then you provide a route spec, and you say route spec, and here you're matching incoming requests that come to this server port and host. So let's say that this server runs on port 9999. Here I'm saying match the path proxy and match the host, start.spring.io, and then send that request to localhost 8080/customers. All right. Well, there's my my predicate and my downstream service. I might want to change that. I might want to use a filter. So I'll say filters.setPath. So actually, what's going to happen is the request will come in with this path. I need to change it. I need to remove that and change it to be customer, so that when it goes to localhost 8080, it resolves to a path that actually exists. So I use filters to make those changes. Filters are where the real power is here, right? Let's say I want to add a header to support cores, for example. So HTTP headers, access control, origin, that kind of thing. I can do a retry. I can do all sorts of things here to make my service more robust. Let's go check on our native image. You can see it's almost done there. But in the meantime, we'll just start up the customer service. Okay. So here's this. We'll start this up as well. So that's an API gateway. API gateways are great for ensuring a quality level of service, a consistent level of service for all your services. It acts as the proxy of the downstream, to the downstream services. Another thing you might do is to create an API adapter. API adapters are great if you want to change the data, if you want to create a new view of the data, to synthesize a new view that didn't exist before. So in this case, I want to create an endpoint that has all the customer and all the order data, right? So I'll say private integer ID, private string name, and here it'll be private integer customer ID, and then ID at data at all-args constructor, at no-args constructor, etc. Okay, so there's my two entities, my DTOs, if you will, and I'm going to create two endpoints to read those data, right, from the different downstream services. So get customers, and we're going to turn this into reactive stream, but we'll do it in a second. And then we're going to have another endpoint here called get orders for integer customer ID, return. Okay, so now we've got two reactive streams, and I want to have another endpoint called get customer orders. I'm going to create a new view of the data, an aggregate that didn't exist before. And this will be a good example of service orchestration and composition, or scatter gather kinds of service orchestration and composition, right? So I'm going to create this new view of the data, and I'm going to use reactive programming to make network calls concurrently and to pull the data back into a form that is useful for our client. Maybe our client wants all the data at once, and rather than making it do the work, we're going to actually do the work for it on the server and then give it back that view. So here I'm going to say for each customer, I want to create a tuple. A tuple is a named array of elements, and I'll have two items in the array. I'll have a customer on the first item, and on the left we'll have the orders for that customer on the right. So we'll say customer.getID, and that's going to be a list. And once I have this, I can then map over it. I have a tuple with two elements. So the tuple has T1 is customer and T2 is list of orders. I can turn that into my aggregate here. And notice that this is concurrent. I'm doing fan out, service orchestration here. I'm doing very convenient work, and yet I don't have any single phasers or countdown latches or runnables or anything like that. No threading code. Remember, there's only one person that truly understands how to write safe, effective, multi-threaded Java code, and it's not you. It's definitely not me either. I don't know who it is, but the point is, use the framework. We need to fix those. So let's actually create two objects to use to talk to the RSocket service. Okay, RSocket requester.builder, and I have to connect to the host on application startup. It's a stateful protocol, so once the client is built, you're connected, and you stay connected, so you don't have to reconnect each time. It's much faster in that respect than it would be if you're using something where you have to reconnect, like HTTP 1.x. Okay, so now there's my HTTP client and my RSocket client. Both of them are reactive, non-blocking. Here's my order service. I'm going to say RSocket. I need to inject the RSocket client, RSocket requester. Okay, private final web client, HTTP. All right, so there's this. Now let's build these out. So .rsocket.route orders CID, customer ID, and then the retrieve flex of order.class. Okay, so there's my reactive stream of RSocket data. Here's my reactive stream of HTTP data. HTTP localhost 8181 customers. Sorry, that'll be 8080. And the data will come, we'll say retrieve and body to flux of customer.class. Okay, so these are reactive streams, but because they're reactive streams, you can do operations. You can say on error resume, whatever, return a default value. You can do retries, right? You can do retries with backoffs like this. You can do all sorts of things, and these are the same operators that are available to you here as here. It doesn't matter if it's RSocket or HTTP. They're reactive types, not network protocol types. So now we have these three different endpoints. Let's go ahead and create a new REST controller finally in the last minute here to show that information. So REST controller, class customer orders REST controller. And we're going to inject my CRM client. And we're going to create a new endpoint here called COs. Turn this.crm client.get custom orders. Very good. So there's this. Now I already have the customer service running in the background, but before I restart this, see, this is the customer service here. Let's see if my native image is built. Yes, it finished building. So I'm going to stop the native image here. I'll stop the customer service there, and I'll restart it with this. I'll say docker run -p 8080, passing in that tag. And so this is a native image that starts up in under 0.2 of a second, and the application will take tens of megabytes, not hundreds or worse of RAM. So that's very, very powerful, very fast. So now we've got the customer service, the order service. Let's run the gateway here. Here's the gateway. Restart, and we're going to test that all that is working as well. So curl -v HTTP localhost 9999/proxy. This will fail, right? This is going to fail because I don't have the host header. So now I say -h host equals hello.spring.io, right? And there you go. You get the data back there. So the gateway is working. Now, what about our API adapter? Well, curl HTTP localhost 9999/COs, and there's our composite data, right? You can see we have a customer, Stefan, with ID 8, and here's all the orders for that particular customer, and it's super fast, and we did all this concurrently. All right, my friends, I hope you got something out of this. I hope you learned a few tricks and tips to build software that is better, ready for production at scale. We've looked at all sorts of things: reactive programming, we looked at service orchestration and composition, we looked at reliability patterns, we looked at observability, we looked at containerization with OCI images or Docker image, we looked at graalvm native images, we looked at just a bunch of stuff that should help you write better software for production to scale like the greats. I want to thank you so much for your time today. I hope you're all healthy, happy, and safe, and I'm now very happy to take questions.
Okay, thanks a lot, Josh, for that great presentation. Seems like you did not start today the coding. You were so fast that I couldn't really follow, but I'm not an IT guy. Although I hope from the audience we will have a few questions. So guys, please use the Q&A part and try to upvote each other's questions. But in the meantime, my first question is that what would be your guidance if someone would like to start this technique? What shall be the basis? So where shall they start?
Well, I mean, building software for production is a big deal, right? There's a lot of things involved. So it's hard to pick any one thing to do. You might check out spring.io/guides, where you'll find lots of little guides that teach you how to get started in 10 to 15 minutes with one little thing. So if you want to build a REST endpoint, there's a guide for that. If you want to introduce security, there's a guide for that. If you want to do lots of different things, you can do all that at the spring.io/guides. And of course, write some code, right? That's the way to do it. Just start writing code and try it out. And obviously, I'm here to help. We on the Spring team are very happy to help. We have Stack Overflow, the tags that we monitor. The Spring team, the engineers that work on the projects monitor that. We have a chat called Gitter. Gitter.im spring -cloud, and this is available to people, and also Spring projects. So these are based on the same names as the Git repositories. So the GitHub URL for Spring Boot is github.com/spring projects/spring boot. Well, we have a chat as well with that same path, except under Gitter, and you can just log in here, and the Spring team, lots of people on the Spring team answer questions. Scotty Frederick's on the Spring team right there. He's a Spring team member. So, lots of people here, all happy to help.
That's really great, and there are people who say you rock. So that was
good. Thank you.
That was a great presentation, in my opinion. And I think we have a question from Balázs. Do you think graalvm native image will stick with us, or it is just nice temporal thing?
Look, graalvm native images, I think, are going to be a real thing, right? I have to believe that, because the Java team themselves are investing in it with Project Layden. Project Layden is not real right now, but at least they've acknowledged there's a need for that, and they're working on that. So it might be a few years. In the meantime, graalvm gives Java applications an advantage they did not have before, right? If you look at the thing that people look at for writing cloud native services these days, it's either Spring Boot or it's like Go, right? A completely different language. And so to me, that just seems crazy. I wouldn't want to rewrite all my business logic in Go just because it compiles to smaller footprint images. And so I think that's going to be a big deal, right? People are going to be very interested in writing infrastructure now, more often than not. And you can do that, actually. You can use the project I was using, Spring Native. It provides configuration that gets fed into the graalvm compiler. That configuration, we call those hints, type hints, because graalvm is, the way it works is it takes all of your all of your code, it does static analysis. Anything that it does not see being used, it throws away. Well, of course, Java is very dynamic. So just because you cannot see it at compile time does not mean that it does not get used. So what Spring Native does is it registers all this extra configuration so that graalvm doesn't throw away everything. It keeps some things so the Java application will work. Well, this is a very, this is a painful process, but at least it's there, and at least we can do it for you, right? With Spring Native. Spring Native will be in Spring Framework 6 and Spring Boot 3 as native, like directly integrated. Right now it's experimental. I expect that, I hope we'll probably release Spring Native GA within the year. And then Spring Framework 6 comes out next year, I think, sometime next year. So all these things are kind of lining up at the same time. All the interesting things that we want to happen are happening right now. People are writing infrastructure with native images, right? So you can actually write a Kubernetes controller using Spring Native, right? Why not? It's an architecture-specific binary, super small, takes tens of megabytes of RAM, very, very, very small footprint, doesn't cost a lot. You don't have to deploy a JVM or anything like that. So, some very interesting possibilities now. I think it's real, yeah. If only because, why not? Why wouldn't you want Java applications that take up much smaller footprints,
Thank you very much for your answer. We had another question, but I think you read it, that when may we expect Spring Native to get out of experimental status?
Oh, yeah, sorry. I didn't read it. I don't even know where to look for the questions.
No, it's under QA. You are not in Hopin, I think. Okay, the next question would be, what's your opinion on using Kotlin for Spring projects?
Oh, I love it. Yes, do it all the time. Like, I love it. I'm a Kotlin Google developer. I'm a Kotlin Google developer expert because I love Kotlin. I mean, a lot of my own personal code I write in Kotlin. So yeah, please, absolutely. And we even support, I showed you reactive programming. Reactive programming is you have to change that. You have to write code with a sort of different flow control than you would normally write. And I showed you some of that earlier with, then many and things like this. But if you want to write imperative style code, while also being asynchronous, you can use coroutines. And we already provide good support for all reactive APIs as coroutines in Kotlin. So you get the best of both worlds. You can write imperative style flow control code while also getting non-blocking event loop centric runtime. And it works automatically. Every reactive stream is now you can use it as a coroutine in the Spring world. So yeah, absolutely check it out. It's awesome. Yeah.
That's great. Guys, if you have more questions.